Hi, I'm Lisa Spelman. I'm the CEO here at Cornelis Networks, and we are at International Supercomputing here in Hamburg, Germany.
And I'm Addison Snell with Intersect360 Research.
All right. Thank you for being here, Addison.
I'm super excited, Lisa, and what a great conference and event for Cornelis. I'm really glad you invited me.
Thank you. Well, I know you wouldn't miss a supercomputing for anything, so I thought maybe we could spend a few minutes just talking about what are your observations? Like, what are you seeing? What are the trends that are kind of coming out as, you were at supercomputing, in the fall, you're here at ISC. What are you seeing in the European market? What's going on?
Well, I mean, the easy thing would be to say AI. Everyone's talking about AI, but we come to a show like this, and I find that there's a real depth to the conversation because what we found in our research is when you talk about the enterprise AI opportunity that everyone wants to talk about, the types of enterprises that are doing on-premises AI work are probably doing it on premises because they also have experience with some previous HPC type of work. They're accustomed to running scalable high-performance workloads, and that makes the story a little more complicated because, of course, we're trying to do AI and bring in these GPU-dense configurations, but we also have to support traditional high-performance computing modeling and simulation workloads, and maintaining a high level of efficiency for that. Now, that's the kind of really exciting conversation that we have at a place like ISC. And the most interesting conversations is where that goes beyond the compute elements themselves into the storage and into the networking.
Well, I think that's a great observation about this shift in the enterprise. Like, the enterprise AI growth is absolutely taking off, but you're right. A lot of times at these companies, it's the folks that were running their HPC, their simulation environment, or their scientific discovery environment that is now applying that type of compute to everything that they're doing.
Right. Yeah, it just broadens the aperture a little bit on what we have to solve.
Yeah, they've got a little more on their plate. So, you mentioned there's the compute, the storage, and the network. I may have some bias here now as a network person. I feel like there's a lot of attention that gets paid to compute, and it's so important to delivering the performance. But I feel like we are also starting to get some recognition that the network plays a pretty significant role in delivering that realized performance. Do you agree, or is that just me because I'm spending all day in the network?
No, it's absolutely true, because what we've seen is that GPU utilization winds up being a dominant discussion after these systems are getting acquired. This is an expensive component. They're putting a lot of them in there, and you'd like to see that hit as high an efficiency level as possible, regardless of what kind of workload you're talking about. You want these systems to be efficient.
Yep, I agree with that. We've put a lot of time and effort to solving what we call the Big Five. Have I told you about the Big Five?
Tell me about the Big Five.
The Big Five, the way we look at it, is the Big Five things that deliver performance for AI workloads and HPC workloads. The only thing is those workloads are different in which they pull on the most. So the Big Five are bandwidth, latency, message rate, overlap, and scale.
Okay.
So when you think of training in AI, that's a massive scale, and it's overlap and collective communications that maybe are the biggest drivers of performance. If you think about a traditional HPC workload, like, computational fluid dynamics or simulation and modeling, less bandwidth bound, but much more sensitive to really high message rates and lower latencies. So those are the Big Five. Does that sound right to you?
It sounds good. You probably need a cool acronym to tie those five things together so they'll trip off the tongue. We'll work on it.
Yeah, we'll work on it. I was proud I had the Big Five. I thought that was fairly catchy.
That is good, yeah. It sounds like you're on a safari.
Yes, exactly. Okay, so we did recently launch our CN5000, which is our 400 gig end-to-end high-performance network that is built to address the Big Five, acronym coming. Is there anything in there that you think customers are going to be most excited about?
Well, I mean, sure, the message around efficiency in general, I think, is important. But then looking at, you've got a heritage in OmniPath before that already had a passionate, dedicated user base, and now the potential to expand that. We're looking at standards-based high-performance networks that go beyond what could be part of a vertically integrated or vendor-specific networking path. And going out into the future of things like UEC, I think, is a major story in the industry right now. I think there's a lot in CN5000 for the industry to really take notice of.
Yeah, well, we think so too, and we're excited about that path to take the architectural correctness of the OmniPath architecture and start adding those Ethernet capabilities and connectivity and interoperability in. So we think that's going to offer a lot. I wanted to close with one final question to you about what do you see as you look out into the future? You're so, connected to so many of the customers and the providers in the space. What do you think these next challenges are that our customers are going to face?
Yeah, it's a good question, and it's one that we talk about with our global user group, the HPC AI Leadership Organization, or HALO. There's that cool
That's
acronym.
a good acronym.
Sliding in there, you got to work on that.
Okay, that one's taken.
The HALO organization really is helping inform a lot of our research going forward, and a big thing that they're looking at is how to design multi-purpose heterogeneous systems that are going to solve all these types of workloads, because the number one problem facing a lot of these organizations is they still have all of their traditional scientific and engineering workloads. 10 years ago, someone told them they had to start doing big data and analytics. Now they have to start doing machine learning, and nobody tripled their budget. So I have to figure out how am I going to put together a cohesive architecture that can utilize all of these components for a diversity of workloads. I think that's going to be the story that really drives a lot of this hybrid HPC AI space through the rest of this decade.
Okay, I love that perspective. We love a converged workload. So let's go out there and we'll have a chance to solve this for all of our customers. Thank you so much for joining us today.
Thanks, Lisa, and congratulations.
All right, thank you.